I'm Ryochi.
I'm Ethan McClellan.
And I'm Josh Desjardins.
And this is a joint project with ME and ECE, and we're doing a project on energy consumption and efficiency initiatives for building 220 and 200 on Pfizer's site.
Here's the problem statement. As you can see, the building in this picture is Gorson site, including the building 220 and 200. Pfizer wants us to provide some suggestions to reduce the energy consumption for the Gorson site. Here's a graph of total energy consumption, and it includes the date and the current. The average current is around 5,500 amps.
Some of the initiatives that we're looking to implement are window shading, which would give us greater control of heat and light in the building, replace outdated lighting systems, and reduce load on air handling units by adjusting room temperatures based on room occupancy to reduce the need for filtered air. Also, we would like to look at the fume hood sashes and keeping them closed at a safe level. So the ways we can do that is an automatic sash closer system, a sash alarm, or stickers and labels to indicate. We can also look at reducing plug load. So all electrical draw unrelated to the HVAC, lighting, and water heating can be reduced via smart plugs.
We'll be looking at automated window shades. These window shades will open and close based on the temperatures outside and inside. They'll lower when you want to keep the temperature inside and either hot or cold outside. The lighting will also turn on or off depending on whether the shades are open or closed. So together, total, these will save about 21 to 38% energy costs, and it'll have a payback time of about 4 years.
So another option we looked into was on the lighting side, and there are some saving potentials. So the lighting automation consists of zones of hour-long timers. So each sensor, there are 3 motion sensors in each lab. The majority of lighting is switched off at 12 hours a day. This is when they're not obviously in the building. We looked into changing light bulbs to LED as they generally have fast payback time. On the right, you can see a chart here that shows what happens if you switched from a tungsten halogen or CFL to an LED and how long it takes for it to pay back. And obviously, as you know, like LED light bulbs do emit light, but they also dissipate heat. So about 40% of the used energy is converted into visible light, and only 60% is into heat.
Additionally, we looked into tuning of the HVAC system as it is one of the largest energy consumers on the site. The lab spaces require 14 air changes per hour when occupied, and the fume hoods within them, which are the biggest energy consumer, are handled by separate makeup air units. These labs use 100% outside air for safety, so the energy consumption is directly tied to the outdoor air temperature and varies seasonally. So as such, we looked into air temperature control and potentially offsetting the air temperature with a change in bulb heating in non-lab areas. This comes with an estimation of 1% energy savings per degree change per 8 hours. The primary focus, however, is to reduce fume hood consumption, which will then result in air handling unit energy savings.
We also looked at ways to reduce the cost of powering the fume hoods in the labs. The yearly cost of powering them is about 2.2 million, and just by simply lowering the sash hood to lower levels is enough to reduce the power it consumes. Options include an automatic sash hood closer, which has full automation for greatest control, sash stickers, which are very cheap and effective upfront, which may diminish over time, and alarms attached to the sash, which alerts personnel when they are away from an open hood too long. This is less expensive than full automation.
So our final option we looked into was reducing plug load. So plug loads alone can contribute to 5 to 11% of total energy use in commercial and laboratory buildings. We can easily implement this by using a smart plug, which can either use a timer-based sensor or occupancy-based sensor. Either way, they're both efficient into saving energy. Thank you for listening to our project, and we hope you enjoyed it as much as we did. Thank you.